Okay, welcome back to the second video of MA 1203 Business Mathematics 2, where we'll learn about linear second order difference equations. Okay, in this video we will learn when the difference equations have constant term on the right hand side. Yeah, so in the first video we learned about homogeneous equation where on the right hand side is 0. Now on the right hand side is a constant term. Okay, before we learn about how to find that solution, we learn about what is a steady state value of second order difference equation. So very similar to the first order difference equations, steady state value occurs when yt is stationary, yeah, which means, yeah, all the values of t is the same as the steady state value, which we call y bar. Okay, so if we substitute to second order difference equation with constant term, yeah, so notice on the right hand side we have a constant here, yeah, instead of 0, right? Then if we substitute the steady state value, we will have this, and if we solve it, yeah, you just have to move, yeah, you take out the y bar, and then you move, you divide b with 1 plus a1 plus a2, right? So this is the steady state value, of course, when a1 plus a2 is not equal to minus 1, yeah, because we cannot have a divisor of 0. When a1 plus a2 is equal to minus 1, of course, the steady state value does not exist, right? And in this case, yeah, when we have a constant term on the right hand side, the steady state value gives us the particular solutions, yeah, or we can say the y par, yeah, the particular solution is equal to the steady state value, yeah. So in general, we have the complete solution, which is the homogeneous solution plus the particular solution, or the homogeneous solution plus the steady state value. Okay, so let's continue with example. Okay, so remember from before that the solution, the homogeneous solution, yeah, is equal to C1 2 to the power of t plus C2 4 to the power of t, right? Okay, so what about the particular solution? So the particular solution is equal to the steady state value, which is equal to b, yeah, 32 over 1 minus a1, 1 plus a1 plus a2, yeah, so here minus 6 plus 8, right? So this is going to be equal to 32 over 3, right? Yeah. Okay, so in this case, we have the solution is the homogeneous solution, yeah, plus the particular solution, which is equal to the steady state value. Okay, the second example is again the same homogeneous equation as in the first video, yeah. So we have here the homogeneous solution is equal to C1 2 to the power of t plus C2 t to the power of t, right? And the particular solution is equal to 5 over 1 minus 4 plus 4, which is equal to 5, right? And in this case, what we have as a solution is the summation between the homogeneous solution with the particular solution. Okay, so what about the convergence, yeah, of the solutions? Yeah, remember when we have when we learn about the first order difference equations, we also learn about the convergence of the solution to the steady state value. Yeah, so here the path, yeah, of the solution, yeah, will converge to the steady state value if and only if both the roots are between -1 and 1. Yeah, so if we consider this one, of course, yeah, because the roots are 2, yeah, the root is 2 actually, yeah, only one root, then this difference equation does not converge. And what about the other example? Here again we have the roots are 2 and 4, and again here the solution does not converge to the steady state solution. Okay, so another problem is if we have initial conditions, yeah, for the difference equation, yeah, then of course with these two initial conditions, then we can count the values of the constant. Yeah, so for instance, this is again the same equations as before. Yeah, but now we have an initial condition of 1 and 2. So remember the solution before is c1 to the power of t plus c2 t to the power of t plus 5, right? Yeah, and now we have y0 is equal to 1, which means 1 is equal to c1 2 to the power of 0 is 1, right? Plus this is, if we put in t equals to 0, this is just 0 plus 5. Yeah, so in this case we have c1 is equal to -4, right? And then when y1 is equal to 2, what do we have? This is 2 equal to c1 is -4, yeah, -4 2 to the power of 1, which is 2, plus c2 times t times 2 to the power of 1 again, so this is 2 plus 5. Yeah, so what do we have here? So we have 10 minus 5, which is 5, equal to, wait, what is the t here? The t is 1, yeah, so this is 1. So this is gonna be 5, and this is gonna be 2 times c2, yeah, and we will have here c2 is equal to 5 over 2, yeah, and of course the solution will be equal to -4 to the power of t plus 5 over 2 t to the power of t plus 5. Yeah, okay, so this is the difference equation with an initial value. All right, okay, so I think that's all for this part of the video. Yeah, and we will see you again in another video, which is the last one, where we have difference equations with function term. Yeah, okay, see you again.